Okay, this is the answer sheet with hopefully a good explanation for the WSB, which is homework. We call it the Weekly Skill Builder number 1. This is for week August 11th through the 15th, okay? I went ahead and started because I made a boo-boo, and so I'm going back. So I've kind of started writing. The first question says, and I hope this is focused. I'm sorry, guys, if it's not perfect. State the divisibility rules for 2, 3, 5, 6, and 10. Use complete sentences. Obviously, if you can see, I did not use complete sentences. 1, because I was running out of room, and 2, because I was just trying to hurry. If you don't, at least for Ms. Krumkoff's class, it's okay. It's always good practice to make complete sentences, but I would, right now I'm more focused on if you know the rules. Okay? For number 2, it has to be obviously even number. If not, it can't be divided by 2. Okay? For number 3, you take the sum, meaning you add them all together, of the digits, and if that number can be divided by 3, then the original number can be also divided by 3. So an example, I did this, it's kind of interesting. I did it above here. If I look at 1, 3, and 5, okay, what I would do is I'm going to add these 3 numbers together. 1 plus 3 is 4, plus 5 is 9. And so can you divide 9 by 3? Well, yes. Therefore, that means that this entire number can be divided by 3. So then I went ahead and proved that it can be divided by 3. Okay? An example of one that doesn't work like this, let's do 121. Okay? I would take 1 plus 2, and that's 3, plus 1 is 4. Can 4 be divided by 3? No. Therefore, this number cannot be divided by 3. And let me just show you. Notice you can divide the 12 nice and pretty, but when I bring down that 1, I have a remainder. So this one does not evenly divide, okay? The rules for 5 is that it ends in a 0 or a 5. So example, 25, it ends in a 5, so it can be divided by 5. 100 ends in a 0, so it can be divided by a 5, okay? Number 6, okay? It's the same as the 3s. I'm going to add it together just like these. However, it also has to be an even number. So example, I know that 135 is not divisible by 6 because it's not an even number. It ends in a 5, so it's an odd number. So it cannot be divided by 6. Okay? And the last one is number 10. The number must end in a 0. Okay? Problem number 2 on Monday. What is the LCM of 9 and 12? Show your reasoning. We can skip count. I can use the sock method or the factor slide. Let me do the factor slide. You're going to put the 9 and the 12 inside the upside down division box. And I'm going to think, what prime number can I divide them both by? Yeah, I'm going to divide it by 3. Okay? If I go too quick on this video, just realize you can pause me at home at any time and play when you're ready for me to keep speaking, okay? What is 9 divided by 3? Correct, 3. And what is 12 divided by 3? Correct, 4. Can I divide 3 and 4 both by a prime number? Well, of course I can divide 4 by 2, but can I divide 3 by 2 evenly to get a whole number for an answer? No. So I'm done. That's as much as I can do. So at this point, the LCM, remember class, the GCF will appear on your left-hand side, but the LCM, you have to take it, it looks like a sock when you're done. Well, this one might not look like it. Okay? And you're going to take all those numbers and you're going to multiply them back together. So 3 times 3 is 9 times 4, 36. So what is my LCM? Okay, you should have noticed that it's 36. If you skip counted, you would have gone 9, 18, then you would have gotten 27, then you would have gotten 36. And you would have noticed it goes 12, 24, 36. Okay? Show my reasoning. I showed my work. I feel like that's really good. Okay? Next one, what is the GCF of 15? I notice it's having a hard time focusing. Of 15 and 21. Show your reasoning. Okay? I'm going to use the same method as above to see if that helps. So 15 and 21. I'm going to do the same thing. Can I divide 15 and 21 both by the same prime number? Not a composite, but a prime number. Yeah, 3 works. Okay? 5 and 7. Notice that these two are prime numbers. Okay? And again, I can't divide them both by another prime number that's the same. So I'm done. So I'm going to go ahead and multiply. Oops, I was starting to do something wrong. GCF is just the side, remember? Oopsie, Miss Kremko's making a mistake. Getting too excited here. I'm creating work for myself. Okay, I love whiteout. Okay, so what's the GCF? Yes, it's 3. Okay. Write 3 prime numbers between 20 and 100. Okay, well, let me see. 21 doesn't work. 22, 23 is a good example. 29. 31. Do you know everyone thinks 51 is a prime number, but it's not? 51 can be divided by 3. I already have 3, but I'm just trying to think of some others. $97. I think 87 is. Yeah. Okay, I'll come back to if I think of some more. I'm sure there's some others. I just, yeah, I'm trying to think. Like 60, I don't know. 67? I think. I'll keep thinking about it. Find the equivalent fraction for 6/9. I like to write my fractions one on top of the other with the numerator on the top and the denominator on the bottom. Equivalent means that they are the same, equal. Notice the word equal and equivalent. Well, not exactly, but it sure looks like it to me. Okay? Explain what equivalent fractions have to do with multiples and factors. So, what's the same as 6/9? Well, you might know that from last year, 6/9 is the same as 2/3. Okay, that's if I cut my pie into 9 sections. Ooh, this is going to be tricky. I'm not good at drawing, but I'm going to go ahead. And I shaded in 1, 2, 3, 4, 5, 6. Well, that would be the same as if I cut my pie. Instead of 9 sections, I cut it into 3 sections and I shaded in 2 out of the 3. Okay. Another one that I could do is it could be the same as 4/6. Another one that could be the same as 12/18. Notice what you're doing is you're finding here a common factor to divide them both by. I divided both of these by 3, okay? So I said 6 divided by 3 and 9 divided by 3. This was my GCF, okay? Notice here 6 to 12 and 9 to 18. I multiplied it, so these are multiples. Okay? Multiples of the original number. Okay? Am I focusing on that? Is that okay? Can you see it? Okay? Tuesday's work. Okay, Tyler understands factors, but sometimes he has trouble making sure he has found all the factors of a number. What advice can you give to help him? Demonstrate by finding all the factors of 32. Okay, one advice I can give, and my students have heard it, is I like math to be pretty. I don't know if can you see? I like math to be pretty, and what that means is it has to be organized in a way that you can understand it. Now, sometimes that looks a little different for you than me, but usually it's just some sort of organization. What I like to do when I list my factors is I like to write it below, and I like to go in order. I don't like to hop around. I'm not playing hopscotch today. I have a system. So what I like to do when I list my factors is I like to start at 1. Is there a number 1 times what gives me 32? You're correct, it's 32. Can I do 2? Well, of course, since it's an even number, yes. 2 times 16. 3? Nope, that doesn't work. What about 4? Yeah, class, 4 times 8. What about 5? Nope. 6? Nope. 7? Nope. And I know I'm done. Hang on a second.